Right, so therefore now, Unit 8 says the rate of change difference and differentiation, rate of change difference. We are all too familiar with the equation to obtain the rate at which the y, the dependent variable y change differs with respect to the independent variable x. Gradient amount is equal to the difference in the y variable divided by the difference in the x variable. Here we have it in symbolic form. M for gradient or for amount is equal to y2 minus y1 over x2 minus x1. But now you have this notation, m is equal to delta y over delta x. This is the symbol for the song in Greek. And because the difference starting with d, the mathematician choose to use the Greek d, all right? Uppercase delta and lowercase delta, d for difference, okay? So this is why you have this version of this formula. Gradient is equal to delta y over delta x, and gradient is equal to delta y over delta x, lowercase delta. It must be noted that the Greek symbol delta, upper and lower, here it is, generally means a small change. Okay, so to communicate a small change, the mathematician chose to use the Greek d, okay, which is delta, or a small difference in mathematics and physics. Therefore, the symbol delta x literally means in words, a small change in x. So just like when you see this, you see it, E-I-G-H-T, it. When you see this, you see T2, okay, T-W-O, 2. When you see this, you have to say a small change in x. Okay, so these two symbols stuck together like that, delta x, in words, translated in words means a small change in x, okay? So whenever you say delta x, you mean a small change in x, okay? Now here you have a curve, well, actually a straight line to be specific, and here's the equation for it. As you can see, the line is going up, and anytime you look at the graph, the line or the curve that you see shows the behavior of the y. Always bear that in mind. X always increases from left to right, but the line will tell you what the y is doing. So since this line is going up constantly, it means that the y variable is increasing, okay, at a rate, okay? The rate there now is 4, okay? Let's talk about that. With careful inspection of the equation, y is equal to 4x plus 5, and correlating that to the standard form of a linear equation, y is equal to mx plus c, it is seen that the gradient of the line AB is equal to 4. This can also be proven by the use of the equation. So you have y2 minus y1 over x2 minus x1, back to that formula there, okay, for mute, all right, for mount. And we have 17 minus 1 over 3 minus minus 1, 16 over 4, 4 over 1. So don't ignore or don't take lightly that 4 over 1. Okay, most times we forget the 1, because the 1 now helps you to define the gradient. All right, so please, from now on, whenever you see gradient, think of the 1 below, and the 1 now below represent the change of x, x2 minus x1. Okay, so that 1 there now is x2 minus x1, that 4 is y2 minus y1. So this is why this is labeled here. The y changes differs by 4. The x changes differs by 1. Okay, so therefore the m is equal to 4 can be interpreted by saying with every unit 1 change difference in x, y changes or differs by 4. In other words, whenever x differs by 1, y differs by 4. Okay, so please always bear that in mind whenever you're talking about gradient. If you have a gradient of 15, it means that the y changes by 15 when x changes by 1, because it's 15 over 1. Always remember that. Okay, the rate at which y changes when x changes by 1. Please bear that in mind whenever you're talking about gradient from now on. I repeat, therefore, the gradient of 4 means that whenever x changes by 1, y changes by 4. If you have a gradient of 15, it means that when y changes by 15, x changes by 1, or vice versa. Whenever x changes by 1, y changes by 15, positive 15. We have a gradient of negative 24. What does that mean? Whenever x changes by 1, the y decreases by 24. Okay, so please bear that in mind whenever you're talking about gradient, and we'll be going over that as we're going through this topic. Now, the phenomenon regarding the rate at which one variable changes differs with respect to the unit change difference of another, together with the analysis of the limits of every small differences, give rise to an important branch of mathematics, specifically calculus termed differentiation. Okay, and there are two mathematicians and physicists also who are credited for pioneering is Newton and Leibniz, and we're still using it today. Okay, to differentiate or to find the different derivatives of a function is the same as finding what can be called a gradient function. So differentiation is intrinsically connected to gradient. Okay, that's why I suspect they call it differentiation. Okay, because that's where it parted from. That's its origins. Difference in the y over difference in the x. So that's why whenever you're differentiation, and why they call it differentiation, and also that's why I am reflecting on that also. Okay, why differentiation? Why they call in that branch of calculus differentiation? Because most likely it's from its origins, difference in y over difference in x. Okay, you are analyzing how those the difference in y change with 1 unit difference in x. So it's logical to give it that name to make that association. All right, and here you have the notations for it. You have dy over dx, or English dy over dx. Okay, remember when you see this, it means small change in y over small change in x. All right, and then you have y prime. That's another notation for differentiation to simplify things, because probably when you're writing your math book, this is a fraction, so it might be too cumbersome to write a fraction. So they created that notation. Remember, it's a language, so you can create symbols to represent something like a code. Okay, so this symbol was created now, because it's less, cumbersome. It's a little easier to write y prime than write dy over dx. Every time you have to write 1, 2, 3, 4, 5 symbols. Here you can just write 2 symbols. So it's easier to write this. And then you have f prime of x. Okay, if you are dealing with a function. Okay, so whenever you see these now in mathematics, it means the same. It means a differentiation. Please bear that in mind. Okay, and here you have the rules of differentiation, and you have examples. Okay, and this now is specifically for a polynomial, ax to the n. Okay, so the differentiation of a function that looks like ax to the n is n times ax to the n minus 1. Okay, and here you have an example, 5x to the 3. 5 will take the place of a, 3 will take the place of n, minus 3x squared. Dy dx would be you multiply 3 to a, as can be seen in the rule, and then you subtract 1 from the exponent. The exponent here is 2 for minus 3x squared. 2 minus 1 is 1. You have 15x squared minus 6x. This is called a gradient function. So this is the original function or equation, and this is the gradient equation. You can use that equation to find gradient. You can use that equation to find the rate of change in certain areas of this equation. If you have a polynomial that looks like ax, the differentiation of ax, x alone, remember the exponent is 1, then the differential is just a, because remember, when you apply this, you can have 1 minus 1 is 0, x to the 0 is 1. So you just ax by itself, then you have a. For example, you have y is equal to 12x, y prime would be 12. Okay, and 12 now is the gradient constant, because bear that in mind, 12x, that's mx. So the gradient is equal to 12. So you can see the proving right there that the gradient is 12. The gradient is equal to 12. Okay, When you see that, you can see the gradient. The gradient is equal to 12. Another example, x, when you have x by itself, just 1 and x to the 1, then the differential is 1 because there's an invisible 1 in front of the x. So let's say y is equal to x, the gradient is 1. You can clearly see the gradient of y is equal to x is 1. And here it is, the gradient is equal to 1. If you have a letter, a number, a constant, the gradient is 0 because a constant will give you a horizontal line. We'll be seeing later down. Okay, so let's say you have f of x is equal to 7. Represent graphically, you're going to have a horizontal line. The gradient of a horizontal line is 0. The gradient of 7 is 0 because there is no change of y. A horizontal line, yes, you'll always have change of x. When x changes by 1, y changes by 0. Okay, if you have a horizontal line. So the gradient of any constant number is 0 because y does not change when x is changing. Okay, so this is a summary of the rules for a polynomial ax to the n. All right.